Ever stared at a jet engine and wondered, how does this monster not melt itself into a puddle of metal? It inhales air at hurricane speeds, compresses it, blasts it with fuel at over 1,500 underground kNz, and spins turbines that cost more than your house. Yet it just keeps going, mile after mile, flight after flight. Today, let's see why jet engines are some of the most astonishing machines ever built. The basics: suck, squeeze, bang, blow. The fan drags in massive amounts of air. Compressors squeeze it tighter and tighter. Injectors ignite the fuel-air mix, creating an explosion of hot gas. Turbines grab this energy, and the exhaust gives you that familiar jet thrust. But here's the twist. Most thrust in modern engines comes from the huge stream of cold air bypassing the core. That's the fan's real magic. It moves a ton of air, making the engine dramatically more efficient. With bypass ratios as high as 12:1, for every kilo of air through the core, 12 kilos zoom around the outside. Airliners go for efficiency, move lots of air slowly. Fighter jets, they want raw power, so they push a little air ridiculously fast. To spin that massive fan, the low-pressure turbine draws power from the roaring exhaust. Modern engines have up to 18 compressor stages, cranking the air pressure higher and higher. By the end, you've squeezed the air 40 times tighter than when it came in. But it's delicate. If the airflow angle drifts, you get a stall. Bang, flame out, disaster. That's why engineers invented variable stator vanes, blades that swivel to keep the pressure stable. Inside the combustor, temperatures blast past 1,800 degrees Celsius, hotter than the metal walls can survive. The secret? Film cooling, superalloys and ceramic coatings, single crystal blades, internal cooling and ceramic armor let turbines spin at 12,000 RPM in white-hot gas. If a blade fails, the whole engine can disintegrate, so every part is engineered to perfection. And what about afterburners? For fighters, it's pure, raw thrust on demand, at the cost of guzzling fuel. The brains? FADEC. Pilots just ask for thrust. The computer handles fuel, pressure, and health checks. So why do engines ever fail? Usually it's birds, debris, or simple wear and tear. The future? Bigger fans, hotter materials, and even hybrid power. So next time you watch a jet take off, remember, inside it's a symphony of physics, engineering, and human ingenuity. Let me know in the comments, what aviation mystery should I tackle next?